You know that feeling, right? You're staring at a math problem and this panic starts to creep in. It's like you're just supposed to have all these rules memorized and none of them really make any sense. For way too many of us, that's our whole relationship with math. It just feels rigid, cold, kind of uptight. But what if I told you it doesn't have to be like that at all? Okay, so check this out. That quote, it's not from some new age self-help book or a modern education guru. Nope, that's the mission statement from a textbook from 1971. It's called Basic Math, and it was written by this brilliant mathematician, Serge Lang. He saw this exact problem more than 50 years ago and was like, you know what? I'm going to write a book to fix this. So, what exactly is this uptight problem he was talking about? Well, it's that feeling we've all had, that math is just this long, boring list of facts and formulas that you just have to accept. No questions asked. You're just told, memorize this, not, here's why this works. In this quote, man, it just gets right to the heart of it. Lang wasn't mad at math itself. Not at all. He was frustrated with the way it's taught. As this endless, disconnected chain of steps that don't seem to lead anywhere. He knew that this approach just completely misses the beauty, the real core ideas of the subject. And here's the thing, right? This is what happens. When you're just memorizing stuff, that knowledge is, well, it's fragile. It doesn't stick. Sure, you might cram for the test and pass, but a month later, poof, it's gone. Because you never actually built a solid foundation. You never got the why behind it all. So to fight this, Lang created something really different. It's less of a textbook and more like a conversation. It's almost a philosophical guide to help you rediscover math for yourself on your own terms. He wanted to help you build that solid foundation that was missing from pretty much every other book out there. Yeah, the whole purpose of the book was crystal clear. Forget those endless chains of theorems. Instead, he wanted to focus like a laser on the big core ideas. Lang was convinced that if you really get the fundamentals, all the complicated stuff later on becomes so much easier to deal with. I mean, how wild is that for a math book? It's totally revolutionary. His main goal wasn't just to teach you how to crunch numbers, it was to change how you feel about it. He wanted to help you actually relax and come at the subject with curiosity, not with dread. So how does he actually do it? Well, the first big piece of his strategy is this relentless focus on intuition over memorization. He never just hands you a rule and says, here you go. Instead, he walks you through the logic so you can discover for yourself why that rule has to be true. Okay, so he uses these classic, famous questions to show you how to think like a mathematician. Take this one. A rational number. That's just a fancy way of saying any number you can write as a simple fraction, like 1/2 or 3/4. The goal here isn't just to get a yes or no. The goal is the journey, the logical journey we take to figure it out. All right, let's walk through this proof. It's actually really elegant. First, we just pretend for a second, let's assume we can write the square root of 2 as a fraction, m over n, and that this fraction is as simple as it can get. Okay, now if we square both sides, that means m squared has to be an even number, and if a number squared is even, the number itself has to be even, so m is even. But wait, if we follow that same logic down the line, it turns out n has to be even too. And boom, that's the contradiction. A fraction can't be in its simplest form if both the top and the bottom are even numbers. So our very first assumption? It had to be wrong. And that's the really crucial part. Did you notice? We didn't use any complicated, crazy formulas. Not one. We just used a simple chain of if this, then that logic. It's just pure reasoning, and that is the feeling Lang wants you to have, the power of thinking your way to the truth. Okay, so Lang's second big move is to break down the walls between different parts of math. He wants to show you that it's not a bunch of separate subjects in their own little boxes, algebra over here, geometry over there. No, it's one big, beautiful, interconnected web. And he just loves showing you the hidden connections between things you thought had nothing to do with each other. All right, let's start with something we all know, the Pythagorean theorem. A squared plus b squared equals c squared. We all had to memorize it in algebra class for right triangles. Simple, right? Got it? And then, maybe a year or two later, our teacher throws this beast at us, the distance formula. And I mean, just look at it. It looks so much scarier, right? It feels like a totally new, totally separate rule that we've got to somehow stuff into our brains. But is it really? Okay, but now let's actually break it down. Look at this. That side A from Pythagoras, that's just the change in x on a graph. The side B, that's just the change in y. And the hypotenuse C? Well, that's the distance, d. Wait a minute. It's the exact same thing. The distance formula is just the Pythagorean theorem wearing a fancy new outfit for a coordinate grid. And this is the magic of Lang's whole approach, right here, that little aha moment. Once you see that connection, you don't have two things to memorize anymore. You have one idea that you understand on a much deeper level. And suddenly, math gets a little simpler, a little more elegant, and a whole lot less scary. So all of this, it's all building to Lang's biggest, most important point. The real goal here isn't just to spit out the right answer. It's not about being a human calculator. The goal is to learn how to think. I mean, just look at his advice for how to read his own book. He literally tells you to start in the middle, to jump forwards and backwards, to look ahead to see why you should even care about a topic. He's giving you permission to break the rules, to just follow your curiosity wherever it goes. It's a totally active, exploratory way to learn. What he's really saying is that this is about empowerment. He's telling you, hey, don't just sit there and accept what I'm saying. Dive in, argue with the book, question things, figure it out for yourself. It's all about becoming an independent thinker. And this last quote, man, it just sums it all up perfectly. Lang isn't presenting his book like it's the absolute final word on math. He's presenting it as a suggestion, an invitation. He's basically saying, hey, here are some things in math that I think are really cool. And he hopes that by the end, you'll either agree with him or, even better, you'll have figured out what you think is cool. And that really leaves us with a pretty deep question. And not just about math, but about learning anything. What if the real goal of education isn't to find the one right way to do things? What if it's about getting the tools and, more importantly, the confidence to develop your own intellectual taste, to find the things that light you up, and then have the freedom to chase that curiosity as far as it can take you?